Hi class, today we're going to talk about volumes. So if I have a box like this, right? And then this is obvious because you can see that the volumes of the rectangular box is length times width times height, right? But if I do not have a rectangular box, but I have just like um, any object, a sphere. Let's pretend that I don't have a nice form like this, right? What we do in calculus is you're gonna take something called a cross section like this. So we have many cross sections and we put them together, right? We put them all together. You take the area of the cross section, you put them together, you get the volumes. So that's the idea. And if you integrate it, you integrate the area, that means you take in the limit of the Riemann sum, right? So that's the idea of taking volumes. I'm gonna do an example with you. We can start that sample, we can start with that sample of a sphere. Now you can see right here, I have a cylinder, I have the rectangular box, and this is what we have for the cross section. Notice that the cross section, the area of the cross sections in the plane P, perpendicular to the x-axis, okay? And then we have from A to B. You see right there? You see that? So they slice the cross section, they put them together. That's how you get the volumes. All right, so for the first example, we know volumes of spheres is 4/3 pi r cubed. So how do we prove it? So you can see we have the sphere right there. It's like a ball, right? Now we're gonna take the cross sections. What you see in there is the cross sections, as you can see, is the circle, right? And then we have R. In this case, R is the radius of the sphere. Now we're gonna have to do the cross section perpendicular to the x-axis. So therefore, we use Pythagorean theorems. You can see that we have x squared plus y squared equals r squared, right? And what you have right there is the y. That y, anyway, that y is r squared minus x squared, right? That y is actually the radius of the circle that we have. For that's we have to consider for the area of that cross section, right? So using the definition of volumes, and A equals to negative R and B equals to positive R right there. So this is A, this is B, okay? I'm gonna take the volume. So the volumes is gonna be from negative R to R. Area, A of x dx, right? But what is the area? The area of a circle is what? What is the area of a circle? The area of a circle is pi r squared, right? That's the area of a circle. So now I'm going to plug it in. I'm going to plug it in. It's going to be pi r squared. So in this case, what is it? It's going to be y squared, right? What y squared right here? Y squared is just, so right here, we know that y squared is going to be r squared minus x squared, right? So I'm going to plug it in. It's going to be r squared minus x squared dx. And then we integrate it. Anyway, have you noticed that this integrand right here is even? So technically I don't have to worry about from negative r to r. I can just take the integral from 0 to r and I double it. Okay, I'm going to take the pi out as well because pi is just a constant. And then so we have r squared minus x squared dx. And then you do the calculation. We get r squared x minus x cubed over 3. We go from 0 to r. So it's going to be 2 pi r cubed minus r cubed over 3. So if you get the LCD and all, so we're going to end up with 4 third pi r cubed. Okay. All right, so that's the first example. The second example I want to show you, is this one right here. We want to find the volumes of a solid obtained by rotating about the x-axis. The region under the curve y equals to square root of x. So you can see that we have the square root of x function right there. You're gonna take a piece of it, right? You're gonna take a piece of it, delta x, and you take that, you rotate it about the x-axis. That's how you get the whole shape, right? So the solid, you can see the solid lies between x equal to 0 and x equals to 1. So I'm going to put it down here. So volume goes from 0 to 1, and the cross sections a of x dx. Okay. Now, hopefully you recognize that the cross sections create what? A circle, right? So just recall the area of a circle is circle. Okay, area of a circle is pi r squared. But what is r in this case? R is from, you see R is from x to the y, so it's from 0 to the square root of x. So R in this case is square root of x, right? So for our equation, the area is gonna be pi square root of x, which is r, square, which is what? Just x, right? So now I'm ready to plug it in. Square root, the integral from 0 to 1, pi x dx. And then we can take pi out, x squared over 2, and then we want to go from 0 to 1. So the answer is just pi over 2.